everyone. So today we'll be discussing advanced SQL. We will start with joins and proceed with subqueries. So at the end of the session, you are expected to define the different terms used in this topic. You are expected also to write queries in processing single and multiple tables in SQL. Then you are going to define the three different types of joins and be able to write different queries using the three different types of joins. And then you are also expected to write non-correlated and correlated subqueries. So to start with, let's discuss first join. So basically, this is a brief review of our discussion from the last semester's last topic, which is the SQL join. So when you say joins, we have it means a relational operation that causes two or more tables with a common domain to be combined into a single table view. So meaning you can join two or more tables with this operation. So we have three common or three most used joins. We have the equijoin. We also have the outer join and the natural join. So when you say equijoin, the resulting table will be based, or the values of the resulting table will be based on the equal values between the tables being involved in the join operation. So only the common values between two or more tables will be part of the resulting table. That's for equijoin. When you say outer join, it is a type of join in which rows that do not have matching values in common columns are also included in the resulting table. So this is the exact opposite of the inner join. And we also have the natural join. So this natural join is a type of equijoin in which one of the duplicate columns is eliminated in the resulting table. So let us now discuss or illustrate the different types of joins. So we have first for the equijoin. When you say equijoin, it refers to the simplest join operation. We call it the simple join, or we write it as inner join, or just simply join. To illustrate the behavior of this equijoin or the join operation, it will, based on the definition, the resulting table will only include the common columns among the tables involved. So to illustrate that example, we have two relations here. Relations A and relation A and relation B. The example, I have here relation A, and I have here relation B. So when you perform an SQL join, you have this query, the query, or what we call the equation. So we have here A join B, or you can have A inner join B. So either of these two equations can be used. So when you say A join B, the resulting table will contain the common columns between A and B. So that is, if you have A join B, only the common values between A and B is displayed as part of the resulting table. Okay. So to illustrate that in SQL, let's have the sample database, the demo database that I have created. So with the demo database, I have here 4 tables. I have the destination, product, destination, export destination, product, sales statement, and sales table. So let's have a demonstration of the join code. So we will try to join the table product and sales statement. So I have here select. So there are 2 ways to use the join. You can have the full table name, or you can simply use the alias for each table. So let me first demonstrate the full table name. So I will select sales statement dot report code. I also have here product dot product code, and then I have here product dot product name. And I have here the sales statement dot quantity. So I wanted to display here the report code, the product name, and the quantity of each product purchased per report code. Okay. The reason why we are able to do a joint operation between sales and export destination table and sales statement is that both tables do have a common column. So let's try to check first before running our SQL code. Notice that in your sales statement table, you have here the columns report code, product code, and quantity. Now, if you will go to your product table, you have your product code, product name, and unit price. Now, when you will check the product table, we have here a foreign key. If you will go to structure, you will have here that the product code is the primary key of, notice, is the primary key of the product table. If you will check the structure of export destination table, you will see that it's not export destination, sales statement table rather. You will see that in the structure of the sales statement table, you have here a foreign key, which is the report code and the product code. Product code refers to the table product, and report code refers to the table sales table. Okay, so since the sales statement table and product table has 2 common columns or attributes, then it is possible for you to perform joint operation. It can be the equi-join, outer join, or the natural join. Take note that join operation can only be used between tables that has common columns. Okay, so let's go back with our illustration. So I have here sales statement, report code. I wanted to check the number of products being purchased per report code. So I have here the columns to be displayed from sales statement, join product on sales statement dot the common attribute or the common column, that is product code, is equal to product dot product code. So it will only return the common values between the table sales statement and product. So this will be your resulting table. Okay. So if you will check, if you will check your product table, if you will check your product table, notice that you have product 105 and 106, but it is not present in your resulting table after the join operation. That is because the 105 and 106, the product code 105 and 106 does not have a corresponding value in the sales statement table. So that is for the for this one. That is for the sales, join operation. Now, let's go to the outer join. So I have here the outer join. So for the outer join, you have two types. You have the left outer join and the right outer join. So when you say left outer join, it is also known as left join. For the right outer join, it is also called just right join. Okay, so let's go first with left join or the left outer join. So when you say left outer join or the left join, you will be focusing on the position of each table before and after the operation. In this case, it's the left join. So when you say A left join B, focus on the table positioned on the left side of the operation left join. So in this case, you have A to be on the left side of the operation left join, and B is located at the right side of the operation. So when you say A left join B, what you need to do is to focus on all the values in relation A as part of your resulting table. So in this case, when you do the left join operation, the resulting table will include all the values in A, including the values that is common between A and B. So this will be your resulting table. Nonetheless, the resulting table will contain null values. Example, if you have a value in relation A that does not have a corresponding value in relation B, still that value in relation A is included in your resulting table with null values present or null values present in relation B. So to illustrate that, let's have this equation. So I have here, I will not be using alias for each table to shorten my select code. So I have to perform a left join between export destination and sales table. But before doing that, let's first check the contents of export destination table. In your export destination table, you have three values. You have for the export destination code, you have 12, 23, and 25. And in the sales table, you have report code 1101 up to 1106. Now let us check how this left join behaves. So I want to display the report code. So I will be using alias instead. The report code, the export destination code, and export destination name. Export destination code, export destination name from sales table S. So in this statement, I defined S to be an alias for the sales table. Take note that each alias is unique for each table. So instead of writing the entire table name here, you just have to use the alias. Okay. From sales table, then we will be using or performing the left join. Left join export destination table, and let's define the alias E. On S dot export the common column between the two tables. In this case, export destination code. So S dot export destination code is equal to E dot export destination code. If we are going to run this code, notice that on the right hand of the on the right hand equation, or on the table preceding, or not preceding, succeeding the operation left join, which is the export destination, it contains null. So notice that in our select statement, it is the sales table located on the left side of the operation left join, and export destination table is on the right side. And in the columns that we wanted to display, we only have one column from the sales table, and we have two columns from the export destination table. So in this case, these two columns from the export destination table, which is placed on the right side of the equation, contains the null values, since it does not have any corresponding value or equivalent value to the sales table. Okay. So let's go to the illustration of right join. So still we have relations A and B. If we are going to perform the equation right join, you have A right join B, then we will focus on the table or on the relation located at the right hand or right side of the operation right join. So in this case, it is relation B. So the output or the resulting table will contain all the values in B, whether it has a corresponding or equivalent value in A, and the common values between A and B. So in this case, the null entry will, if there are null entries, it will be on the left-hand side part of the output, which refers to the table at the left-hand side of your right join operation. So to illustrate that, let's have another example. So I have here a query between sales statement and product. So if you will check your sales statement table, you have these values or values. And when you will check the product table, you have products 101 up to 106. But in the sales statement, you have only 101 up to 104. So when you perform the right join, the left hand side, the right hand side will be uh, included all in the output. And the null values will be located on the left hand side. So I can check, select sales statement. Let's use an alias S for sales statement. Statement. And then S dot report code rather. Then I have S dot. So I will be getting product code from the sales statement. Product code. Then let's go to the product table. I will assign an alias P for the product. So I wanted to display the product code and the product. Let's try to check the exact column name. It's squad name. Squad name. So in this case, as the report code and as the product code is coming from the sales statement table, and P the product code and P the product name is coming from the product table. So from sales statement, and then I will define the alias S. Right join. Right join product. I will define the alias P. On S that the common values between the two is the product code. Product code is equal to P dot product code. So notice that the null entries are being presented or shown on the columns that are under the table located at the left-hand side of the equation. So just remember, if you're going to do left join, the null values will be at the table or the columns of the table located at the right-hand side of the equation. And when you do the right join, the null values will be located on the columns of the table on the left-hand side of your operation. So now let's go to natural join. So when you say natural join, what happened to natural join? When you say natural join, it is like an inner join or the equijoin, similar to equijoin. However, it eliminates redundant columns or repeating columns. So all you have to do is to use the natural join as your operation. So we can have here A natural join B. So what will be your resulting table when you have A natural join B? So you will include all the values in A, included si tanan nga values ni A. Also, the common values between A and B, and all the values in B. So tanan sila appeal except that repeating columns are eliminated. Okay, so let's try to have an illustration. So let's have here the natural join. Select all from export destination, natural join, natural join, sales table. Say, no, sales table, sales table. And then it will give you the output. So notice that the common columns between export destination and sales table, which is export destination code, is only displayed once. So there is no redundant display of common columns. So this is how you do natural join. So that's for the natural join. You also have union join. When you say union join, it includes all the common columns from each table in the join and an instance for each row in the table.